Alright, good afternoon everybody. We got a pretty quick topic this week. I want to talk about SolidWorks utilities, and we'll really jump right into it. Quick note here, I'm pre-recording this the day before. I'm going to be calling into this meeting, so if you have any questions, feel free to put them into the questions area and I'll get to you. I just can't do any live demos today, like past lunch and learns. Alright, SolidWorks utilities. So what are we talking about today? Our agenda, we're going to talk about some compare options that live right inside your basic SolidWorks. So comparing features, comparing geometry, and going up to the assembly level and comparing bills of materials between both an assembly and a drawing. We'll then look at a feature paint, which is my new favorite feature that I've learned about this past week. Geometry analysis, a symmetry check to verify if our part is perfectly symmetrical or not, and then a report manager, which each of these utilities that I just mentioned can generate its own report, and we can look at each of those reports and generate a portfolio of those different reports. So jumping right into it today. Our first feature, or our first utility that we're going to look at is the compare features. And what this tool will do will show unique and modified features between two SolidWorks parts. So I'm going to jump into SolidWorks here, and we'll look at our two parts to start with. So the first one I'm going to see on our left side of our screen is called Angle Clip 0. Let me zoom out a little. So Angle Clip 0 is something that I created, and I was happy with the design. I sent it off to my team of engineers, and what I got sent back was Angle Clip 1. This tells me something has changed, and I don't really know what they did. So one thing I could do is go through each of my feature manager, look at each sketch, see what changed, kind of do it the longhand version, and say, nah, that still looks good, that still looks good. What we can also do is use this utility, which is going to live under Tools, Compare, and we're going to do Features for this one. And over in my right side here, I have a Compare Manager. And what this is going to look for is both a reference doc and then the modified doc. So for my example, I was the original creator of this Angle Clip 0. So that's going to be my reference doc. What I want to compare it to is the modified doc, which came back to me as Angle Clip 1. For this one, I'm looking to compare just the features, and I'm going to run the comparison. So what this will do is go through my entire feature manager, and it will realign my two windows that I have open, and give me a comparison of which features have changed between my original one and my modified one. So as I click over here, you'll see that I get a broken up display now. And as I click on my countersunk for M10, I start to see where the differences show up. So my type of hole that I was cutting was, in my part, the reference part, was a countersunk blind, where the modified got changed to a countersunk through, which meant my end condition was up to this back surface here, where theirs went all the way through. You'll also notice as I'm moving this part around, they're going to move in unison. So when I have my compare wizard running, the parts move as one. So as I zoom, I know what I'm looking at, because if it's a large comparison, I may not know where I am in the part. So another example here is this chamfer, which shows up in mine, and it doesn't show up in Angle Clip 1, which means somebody accidentally deleted this or removed it for a reason. So as I flip over my part, I'll see highlighted in red that, yep, I have a chamfer in Angle Clip 0. It's not there in Angle Clip 1. Something's definitely up. I also have a cut extrude where my sketch geometry changed. So I know that there's a change there. I just don't know really what it is yet. I can take some guesses that a hole got smaller or moved, but right now all I know is that 3 features have been edited from my original. So a pretty quick way to compare some features between similar parts Also helpful if you have created a part in the past and you're working on a new project and you know that it's going to be close, you can compare it to an existing part and say, yep, these are the modifications I have to make to get it up to this standard. As always, we have some customization settings where we can change our units that we're looking at. For our features tab, we can change the colors that are displayed. So for a modified feature, we might want to pick a brighter color than that yellow and do blue, so on and so forth. What we also can do is go ahead and hit the Save Report button. So what our Save Report will give us, and this is our feature, it'll give us the ability to create a folder. So right now I'm just putting it in a Lunch and Learn Reports folder. Hit OK. And add it to a design binder. So what this is now it'll be a collection of all the reports that we've done throughout our, or I guess my demo today. So I'll go ahead and save that. We'll get back to that at the end of the Lunch and Learn today. So that's the first one, just to compare features. Going on to the next one is compare geometry. So kind of in the same step as compare features, we're now looking at the differences, not in just our feature manager and what changed, but we're looking at part faces and volumes for our two different parts now. So we already understood that something has changed. Now we want to go ahead and see what the cause of those changes, or what the effect of those changes are. So I'm going to go ahead and get out of my my compare wizard here. Just hit the red X. And keeping these open, you'll notice that I lose that connection between the two. Now these are individual parts again. And again, I'm going to come up to Tools, Compare, and this time I'm going to do Geometry. Very similar interface. We're still in our Compare interface on the right side. Again, my angle clip is my reference document, and my angle clip 1 is going to be that modified document. We do have the ability to do align parts, and this comes in handy if it's not a part that you've created. Maybe you're grabbing it offline or a customer sent it. You want to be able to align those parts around a coordinate system, because this is going to be looking at the distance between the origin in order to understand the geometry. With these ones, I know they both came from my system, so I don't need to align the parts. I have geometry selected. I'm going to go ahead and run that comparison. So again, my parts are now combined, and I get a whole bunch of different colors. What do these mean? So the first check that I'm going to do is a volume comparison. And like I said during the PowerPoint, we have two different methods here. We have a volume comparison or a face comparison. So going through the volume comparison, right now I'm looking at just common volumes. So looking at these two models, my angle clip 1 down here, most of the volume is the same, but you'll notice that my chamfers here. So all this is doing is overlaying the two entities and saying, where do these meet? Much like a combine tool. So you can use that combine to add, subtract, or do the common. So this would be the common of that. When I look at what material has been removed, and this is where it really comes in handy to have these two parts linked up, we start to notice that I'm missing a little cut right out of this edge. And that's going to be coming from the fact that angle clip 1 was a through hole versus the end condition of this face. So this through hole has made a cut, and that's now removed material from my original. Last thing we can look at is added material. And now we can better understand why that cut extrude from earlier had changed sketch geometry. We'll now notice that it made our hole, or my original hole, a little bit smaller and added this material to the part. We also have our chamfers that we knew about already. So this material has been added back on to make this a perfect edge versus the chamfered edge. So we have those three added features here. One small removed edge of material there, For the most part, our volume is pretty much the same, but these parts are definitely different. There's been changes. On the other hand, we can do a face comparison, which will show us that geometry that's been changed just based on any movement away from the original origin. So when I start with my unchanged faces, gray is a tough color, but for the most part, our model is pretty unchanged. And again, I can go up to the settings. I'll do that real quick just because it is difficult to see. So we're on geometry, do color, and this would be a, oh, we can't actually change that one. Fair enough. Alright. Alright, so ignoring the gray, we'll go ahead and look at unique faces. So these are now faces that are missing from one another on the other model. So for this instance, our smaller hole is a unique face, where my wider hole is also a unique face because they don't match up perfectly. Our chamfer edge is just unique on my model and not unique on this model because it doesn't exist. As for the modified faces, this entire face is modified due to the fact that the chamfer doesn't exist there. These two faces are modified based on the fact that this through cut now exists where it did not in my original model. So another quick indication to show where changes have occurred or where modifications have occurred and what's unique about those modifications. Alright, our final compare out of this set of utilities is the bill of materials compare. And what this will do is check for consistency across two different BOMs, and it will look at columns, rows, and the values inside each of those columns and rows. So for this one, you're working on an assembly, and you realize, hey, I've created this assembly in the past, maybe I can just reuse that. So you go ahead and you compare them, and I'll open them up in SolidWorks, and we'll look at the comparison to see if there's anything missing between these two. So here I have my collision assembly number 2, which is my older one. Throw that to the left side. And my collision assembly number 7. So this one's further down the line. So I'm looking at these two, and they move the same. They look pretty good. I'm just going to get out of this real quick. So they look really close. I can tell right away that my bill of materials are slightly different, but I want to know all the details I can get out of this comparison. So this is a real small example where I only have 4 item numbers. You can imagine on some of your bigger assemblies where you're talking about screws, anything coming out of the toolbox, you'll start to notice that it's harder and harder to read some of these bill of materials. So again, I'm coming up to Tools, Compare. For this one, I want to do my bill of materials, or BOM. This one, my reference document is going to be collision 7, because that's the one I'm currently working on. My modified document is going to be collision 2, which is the older version, and I'm doing my bill of materials. So if you have multiple bill of materials, maybe for each subassembly, you do have the ability to select them here. Also, if you don't have your older model open or your current model open, you can always come in and search for it. So it doesn't have to be open to do this comparison check, and you'll still have access to that metadata inside your bill of materials. All right, the last thing I want to do is pick the criteria for failed rows. So as I'm comparing these two tables, I'm just going to go with item number. I'm going to choose which one is going to sync up the best and then look for failures in the comparison there. Now I'll click Run Comparison. And again, I can see both my models. We're not really concerned with the models in this instance. We're more concerned with the bill of materials, so they don't sync up like we did before with our compare geometry and compare features. What we do now have in our compare sidebar here So what I now have is some comparisons of my columns, my rows, and the failed rows based on that criteria that I picked earlier. So the first one I'll look at is some missing columns between these two parts, or between these two bill of materials. And even though my order has changed, I still have an item number first, but my quantity over here is at the end versus the second. Description and part number still line up but are different. But what I do get is a missing column. So between collision 7, which is my newest one, and my original, I realized I went in and added the SolidWorks configuration. So that's either an indication that it's not required or it wasn't required in the past, and I'm now adding it. But it gives me that heads up that, hey, if I'm delivering this to a customer, they're okay that I didn't deliver it last time. Maybe I need to go ahead and remove it. I don't have any extra columns between my modified version. I do have a missing row. And the missing row will look at that first row number, which is our item number, and say if anything's different in any of these, I'm going to throw a flag saying, hey, something's up here. So our missing row in our top one is base 07 because it's not in our modified version. Same thing goes for our extra row. So this one is now looking for base 07. It's not there, but it has a base 02, which has changed. So it's now telling me, you're working off different configurations. That this one has an original base that this one does not have. So going back up to my bill of materials here. There we go. I can now look at my failed rows based on the item number and say, all right, where are my differences? And like I was just saying, our bill of materials number 1, the value is base 07. Our bill of material 2 is base 02. And that's where my discrepancy lives between these two assemblies. So for my new assembly, I can either roll back to this older base, or maybe that's the part that needed to change, and I just verified that, yep, everything else is the same except the base, which I've updated. And it's just that quick sanity check between two bill of materials. And again, small example, you can imagine as these bill of materials grow longer and longer, where you might have some discrepancies between two identical assemblies, or thought to be identical assemblies. All right. I said this earlier, Feature Paint is our next utility, and learning about it this past week, it's quickly become my favorite. So it gives you the ability to copy a feature parameters and apply them to an existing feature inside that same part. So imagine you're designing this part on the left. Your boss comes to you and says, hey, we got a design change. We no longer are buying countersunk screws. We need everything to be counterbore. Or we're no longer buying counterbore screws. We need everything to be countersunk, and they have to be this size. Let's look at this part in SolidWorks just to understand what type of hassle that might end up being. So we've designed this part. We're happy with it. We've chosen countersunk up here. We have counterbores on our sides. We have another countersunk set in the back, a little bit smaller. Boss comes to us and says, nope, that plan's been scrapped. That plan's been scrapped. We now need to do everything as a countersunk. All right, what's that really mean? So we now need to, let me close out of this. We now need to look at all the instances where I'm not using this countersunk number 3 flathead machine screw. The first one we look at is this counterbore, where we can come in, either edit the sketch, go back, edit the feature, have that open up, change it around, switch it over to countersunk, so on and so forth, get the right size in there. It's kind of a painful process. I already know that it's going to end up being this feature. All I want to do is have the ability to copy it and apply it to that. So this utility lives under Tools, and then we're going to go to, it's called Feature Painter, or Feature Paint. And again, we're using our right side. We're in the Feature Paint display area now. And it's going to look for two things from you. It's going to look for the properties that you want to copy. So for this one, I want to copy that countersunk. So I'll click countersunk. It will apply it to my copy properties. When I click on this, I can see all the properties that I am copying. So I'm getting everything from the type of hole, the standard, the screw type, the size, even down to the sketches. So our through hole diameter is 0.11, the countersunk angle. We even get the color based on the appearance that we've applied to it. So everything that was associated with that one feature is now copied into our database. Say we don't want the color to come over, we can turn this off and we'll lose that ability to paste appearances, which is all our ambient occlusion, shininess, all that goodness. So we'll turn that off. And now it's going to ask us to where we want to apply this copied feature. For this one, we want to apply it to our counter bores on the sides of this part and to our countersunk number 1 on the back of this part. And it's only applying it to this individual one because we have a circular pattern following it. Same with this mirror up here. It's only applying it to these two. They'll get translated down. So now that I have these selected, get a good angle here, and I'll hit apply. And what this does is regenerates our model. So our counter bore is now a countersunk number 3, and our countersunk number 1 is now a countersunk number 3 as well. And all features are now identical based on a copy paste. So really useful tool if you have to make a mass change to many features. You can really paste as many properties, or paste to as many properties as you'd like, and do that quick change for you. So I was really excited to find that one out. I'll close that down, jump back here. Alright, geometry analysis. Second to last one here. So what this one allows us to do is check a model for insignificant geometry, any sharp edges or discontinuous geometry. So if you're bringing in a model that may not have been a SolidWorks part, you're bringing it in as a step or any other file type, and something looks a little bit funky, or if you're machining a part and you have specific I guess allowances for a drill bit to fit in or a machine head to fit in, and you designed it too precise that you're no longer going to be able to design it or to manufacture it. So let me bring this up. There we go. So we're looking at this part, and it looks pretty good from just a model aspect. These look rounded enough. And we go to the process, or we're about to go to process and machine this, and something says it's not going to work, and we don't know why. It wasn't in our model that we're seeing this error, and now all of a sudden we have this error. So a quick way to check this before we run into an issue on the manufacturing floor is to do a geometry analysis, and this one lives right inside our Evaluate tab. We can also get to it by using Tools, but the shortcut is right here. So this one is under Tools, Geometry Analysis. We'll click on this. What we now get, I'm going to tweak this a little bit. We now get the ability to look at some parameters. So any insignificant geometry. And this is going to include a short edge, a small face, or a sliver face. So anything that is smaller in this instant than 0.1 millimeters. And we're also going to look for sharp angles, so any edges that come to such a sharp point that they're going to be impossible to create or manufacture. So we call them knife edges and knife vertices, so any points that just aren't realistic. They may be able to model, but that doesn't always mean you'll be able to create it. We'll also look at discontinuous geometry, so any floating faces or edges that somehow came in but don't really belong. Big or a larger issue when you're working with surfaces and trying to create them into solids. You'll get some of those floating faces or edges that you'd have to go in and delete. This will catch it for you during the geometry analysis. So this first run, I have some pretty small settings, and I'm going to go ahead and calculate it. And it'll run through each of my faces and edges inside this model. And what it returns is I have nothing that met those parameters. So looking back at this, so I'm going to go ahead and recalculate because looking back at this report, I realize 0.1 may not be realistic, a realistic spec for my machines. So what I do know is I have a drill bit that can machine up to 1.5 millimeters. So anything under that 1.5 millimeters, I won't be able to create realistically. So I'm going to redefine my settings to be 1.5. So I don't want any faces under 1.5, any sliver faces, so any real tight edge faces under 1.5, or any edges for that matter to be less than 1.5. Same thing, I can go a little bit lower here, so anything less than 1 degree for my vertices would be too sharp for the tools I'm using. And this time I'm going to calculate it again. And now that we've applied some realistic boundaries to this analysis, we'll notice that we do have short edges, we do have small faces, and we do have a lot of sliver edges. So our short edges and sliver faces, are kind of our biggest problem in this model. And each of these I can open up and go ahead and get a good zoom in on. So looking at this real small face, I'm starting to realize that I may not be able to machine this. I realize that this face may not be machinable, or may not be necessary. Maybe I want these two edges to meet up, and I can remove that small geometry that's there just by design, or maybe not by design, but by the shape of this part. So it gives you that heads up that says, hey, I should probably do some cleanup here to get this as smooth as possible. I don't want this little flat edge here. We can go through all our faces here and realize that, yep, this is how it was designed. Maybe that's not the best design, and I can go ahead and clean that up. And that's what geometry analysis will buy us. We can look at all our slivers as well. Let's go around here. Now get the sliver face coming through here. This might be good information, so I'm going to go ahead and save a report. This one would be called Geoanalysis. I'll add it to my report design binder and go ahead and hit save. Alright, last one here, our symmetry checker. So what this does is gives us the ability to check for symmetry about a part, or for a part about a plane, as well as reducing that part to the smallest symmetrical piece. I'll jump back into SolidWorks and show you what I'm talking about for this one. So we're done with our geometry analysis, and we're on to symmetry. Alright, so I'm looking at this pretty simple part, and looking at it, I would say that this is in fact symmetrical. I'm coming across this face, I'm coming across this face, everything's at a 90 degrees. Looks pretty good. Just want to verify before I go ahead and say, yep, everything looks good, let's go produce it. I want to do a symmetry check. And again, I'm under my Evaluate tab, click Symmetry Check. And the first plane that I want to do is my right plane. So I have that selected. And I can choose some colors for my settings here. I'm happy with red, green, and yellow. And I'm going to go ahead and do a check. I get a pop-up that says the part is symmetric about the selected right plane. So, all good, everything's green, checkbox. You like those. I'm going to go ahead and save it, prove to my boss that my symmetry is good. Alright. Got to do one more recheck real quick, just before I get too confident. And I'll check it along the front plane. Go ahead and hit check. I didn't get that happy dialog box. I now no longer have a fully green part. I get the symmetry check results where I have two unique faces and a couple asymmetric faces. So the unique faces are the ones I'm most concerned with. And as I flip this over, I realize I have some red underneath. So I have side A and side B are not symmetric about the front plane. Side B, side A. And as I look at this a little bit more, I realize this underside of, we'll call this a propeller just because it's simplest. The underside of this propeller has a filleted edge where these three do not. So it looks like something got missed doing a mirror. So I'm going to save this report just as a reminder that something's a little funky here, and exit out of my symmetry. So I have a circular pattern here for all four of these little propellers. I'm going to go ahead and edit this. And what I want to do, I want to include that third fillet. So that's the part that got missed in my symmetry check. And it passed symmetry because, in fact, along the right plane, it's still a symmetric, even though this is flat and this is filleted. Where it failed was this front plane, where the fillet did not mirror pretty much over the front plane to this other side. So I'll add that, go ahead and hit OK. And I'm going to run my symmetry check one more time, again about my front plane. And go ahead and do the check. This time it comes back. We have 25 symmetric faces, 0 unique faces, 0 asymmetric faces, and I get my happy, the part is symmetric. So I say OK. What I can also do in this, now that I know that I'm perfectly symmetric, say I want to run some simulation on this part. I can run it on the entire part, but that may take a little bit longer, where all I really need to know is stresses of the smallest produced replication of a symmetrical piece of this part. So my analysis is going to yield the same results if it's on the whole part in a specific section or a specific section of this whole part. So what we can do is do an automatic symmetry split. And this will cut down our part into the smallest piece of symmetry that it can find. So we can cut this part along the front plane, which yields this half. We can cut it into a quarter, which will yield this piece here. We can even go down further and cut it into eighths, which yield these two pieces, which are symmetric along this diagonal axis. So the body I want to split is this smallest entity right here. I'm going to go ahead and split the part. So with this split, I can come in here and save it if I need to. But what this gives me is the ability to run a simulation study on just this piece, which would be quicker and just as accurate as running it on the entire propeller. So a quick way to find the smallest entity that can be produced or replicated to produce your final part. Just do Control-Z to get my final part back. Pretty powerful stuff with just a couple clicks of the utilities. So the last thing, so as I've been going through these utilities, I've been saving out reports somewhere on my desktop. What can I actually do with them and how do I get to them and manage them? And that all comes with the report manager. So it gives us the ability to find and organize reports generated from these utilities that we just went through. So if I come into my tools and under compare, so back where we started, we have this report manager. And what I now need to do is I've been saving out all these reports as I've been doing them into this lunch and learn reports. So I'll select that folder, go ahead and hit OK. Now we can see all the reports that I've been saving as I've been running through my different parts and assemblies. So I have my bad symmetry example, my good symmetry example, my geometry analysis, and then this one's my feature comparison. So I have these all organized inside one single folder. Maybe I want to view them. And what the report comes up as is an HTML, and I'll expand this a little, which shows us the name of the report based on what we called it, where the part lives. So mine is living under my name with some app data, long string, but ultimately the file where it started from as the reference part, as well as the modified part and where that lives, when I created the report and who it was created by. It also gives a summary of these results. So for this one, this is our compare features report. We have one unique feature coming from our reference part versus our modified part, and 2 modified features, 4 identical features, 0 uncompared features. Our unique one ended up being that chamfer in the bottom of the part. We also had some modified features for that cut extrude, which was a little bit smaller based on the sketch geometry, and our screw end condition. This one ended up being a through wall for a modified part, or so a reference part stopped at the back edge of our plate. And we can see those details here. We'll also get a current view of our 2 different parts, so both our reference part and our modified part. Now this can be sent out to a customer to show them this comparison. It can be sent to a manager if needed. You can also look at some bad examples here. So we'll view this bad symmetry report. And again, it will show as our current view the unique faces of where they occur. You can't really see too well in this view. But again, shows you where the part lives when the report was created. And it always gives you that ability to save. You can also do a couple other things where we can export these reports, put them into a different file if need be. We can change the folder. You can bring reports from different computers onto the server. Anything like that would be under export reports, as well as change folder for any of these reports. So based on that, that was pretty much what I wanted to show you today in SolidWorks utilities. They're very powerful, and there's a lot of value into learning what these utilities can do, because they'll ultimately save you time and some frustration when you're trying to compare and contrast 2 different parts or understand where a change might have been made. I hope you learned something. Please ask any questions now, and I'll respond to you, or I'll follow up with an email. I hope you have a great rest of the day. Have a good one.